Okay, hello everyone. So we'll go through Maths Paper 2 here on the higher level. Reasonable exam. There's a mixture of some very easy questions and some very tough questions. So we'll get along to them when we get there. But yeah, it's an okay exam. Okay, so question 1 then, fairly routine. Checking if point is on a line. All you got to do there is sub the point into the line and it'll all work out. So 3p minus 2 bracket 5 plus 28 equals 0. 3p plus 18 equals 0. Bring the 18 over, get minus 18, so p works out as minus 6. And it just wanted the value of p, so that's fine. So then down here, we want to work out the angle, the acute angle between two lines, so we need to get the slopes. So the slope of the first line, we call it m1, is minus a third, because this is in y equals mx plus c format. And then the slope of the second line is, when it's in this format, it's minus what's in front of the x divided by what's in front of the y. So that works out as 2 over 5. So minus what's in front of the x divided by what's in front of the y. And then we sub that into our formula for the angle between two lines. That's the tan theta equals plus and minus m1 minus m2 over 1 plus m1 times m2. So that's from your tables book. So I'll just sub it in here. So we have minus a third on top. Minus 2 over 5 over 1, and then you multiply it, you go plus, multiply together, so that works out as minus 2 over 15. Okay, you tidy that up, taking the negative here to force the thing to be positive, you get tan theta is equal to 11 over 13, and then you take the tan inverse of that, and theta works out, I think, to the nearest degree there at 40 degrees. Okay, so that's the acute angle. That's reasonable enough, easy enough start to a paper. Okay. This is a good question. Yeah. So this is good. This is good to be telling them to do this, to draw a diagram. So a slope of minus 2/3. The triangles that makes, and you can do a proper sketch of this as well. You're not just drawing any random line. You can actually properly, do the run 3 units, fall 2 units kind of thing. And you can do a good sketch of what a slope of minus 2 over 3 looks like. So the two lines, the two triangles that can be made are one that looks like this, and then another one that looks like this. So there's the triangles are in the first quadrant and the third quadrant, like such. So then you just kind of, when you're solving this question, you want to maybe just work with the first quadrant one. You mark in these points here. So then this point here is the y-intercept, which will be 0b up here, 0, b. And this is the x-intercept, which is a0. Okay. And then the area of the triangle then is 12. Okay, that's everything there, reasonable. Now, you can write because B and A can be negative, right? When you're writing the sort of areas here, you want to maybe work with the modulus. That's one clean way to do this. So I would say you do half base times height, half the base times the perpendicular height. So this will be 1 over 2 multiplied by the modulus of A times the modulus of B. I'd set that equal to 12. So then I get an equation, modulus of the two guys equals 24. Because as I said, those two pink points can be down here and here, and then they'd have negative values. So that's a good way to not worry about things. The other then piece of information we've got to bring in here is the slope. So the ratio, in general, what we're going to be doing is we're going to be falling 3 units and falling 2 units and running 3 units. Okay, so that tells us information about the ratio that A and B are in. So in general, A divided by B is equal to this ratio of 2 over 3. So yeah, so I done that the other way around. So I want rise over run. So B over A, That's the rise over the run is in the ratio of 2/3. Something like that. Will do fine. So then you can, so like what we have now is the question's kind of solved. We have two equations and two unknowns, so it's just a bit of algebra from here. So what I'll do is I'll get the b on its own here maybe. So the modulus of b equals 2 times the modulus of a over 3. And then I'll sub that in to here. So I'll get 2 times the modulus of a squared over 3 equals 24. Multiply across by 3, divide by 2. I get that the modulus of a squared is 36. Now I'll take square root of both sides. It would be something, after you take the square root of both sides here, it would be that the modulus of a is equal to plus or minus 6, but like it can't be the minus 6. You have to throw away the minus answer, because after you take a modulus, the number is forced positive. So you're getting that the modulus of a is 6. So then the answer is that a is equal to plus and minus 6, right? And when that happens, when you sub back in here to get b works out as 2/3 that, so it's plus and minus 4. So the 2 points here, if I get another color for blue here, this point here, when this is 6, 0, this point here is 0, 4. And when this point here is minus 6, 0, this point here is 0, minus 4. Okay, yeah, I'm happy with that. That's, yep, 0, minus 4, minus 6, 0. So they're the points. Okay, yeah, that was a good question. A good diagram helped things a lot there. Okay, Grant, moving on. This was a nice question here. Very straightforward circle stuff here. So you got center, the center there. Let me zoom in. So the center there is 4, and then minus 2. So change the sign. Change the sign there, yeah. And then the radius here is root 45, like such. Okay. So then find the equation of the tangent that's made at that point. So easy enough. You just need to get the slope. We're missing the slope of the tangent. So we get the slope of the tangent. If I was to draw a diagram of this for those who didn't get it. So if you join the center of the circle to the line, it makes a 90-degree with the tangent. So what you do is you get the slope of this line first, and then to get the slope of this line, you flip it and you change the sign. So it'll be minus 1 over the m. So grand. So we get the slope anyways of that first line, which is done with using the center of the circle and the point on the tangent. So I'll write them in now. 4 minus 2. Minus 2 minus 5. So the slope, I'll label them up. 2. M is minus 5 plus 2 minus minus over minus 2 minus 4. So that's a minus 3 on top and a minus 6 on the bottom. So that works out as a half. So then the slope of this line, the tangent's line, is minus 2. That's the actual slope we want. It's the perpendicular slope. So then subbing in, and we have to give our equation in this format here. So that's grand. So then we go y minus y1 using the point on the tangent. So that will be a plus 5 equals the slope, which we got to be minus 2, x minus x1, which turned to a plus 2. Multiply that out, bring it all, so the y is on its own. You should get y equals minus 2x minus 9, like that. And that's good. And yeah, I drew that up in Desmos, and that is the correct answer. So that's okay there. So easy stuff so far. Okay. So then, yeah, that's that done. So then on to this here with the circles. This is a good question. They give a hint here. They didn't have to give this hint that this is a horizontal line. It's kind of expected to know that when y is equal to a constant value like that, it's a horizontal line. So again, what we want to do here is draw a sketch of this to understand what's actually going on. So what you'll get first of all is the center and the radius of that circle. So it has a center of minus 14, so you half and change the sign. Plus 23 then on the y, and then the radius. The radius is equal to the square root of, doesn't matter with the signs here because you're squaring, 14 squared plus 23 squared, and then minus c, so that's a minus k there. And then when you tidy that up in your calculator, you get the square root of 725 minus k. So we know information about the circle now. So we're going to do a sketch of this. And you can do a reasonably representative sketch by putting the circle center in the quadrant where this center is. So that's the second quadrant. So I'll draw some random circle here, like such. And then there's going to be two possible horizontal lines. And what these horizontal lines look like are like this. There's one up there above the circle, and then there's one below here, like such. Now, the easiest way to get this, now there's other ways, there's multiple ways to get this. So what you can just use is the perpendicular distance formula, where you set the perpendicular distance to one of these lines equal to the radius. Okay, and so the equation of this line to use this formula, so this is y equals k, but what we'll do is we'll write that in the ax plus by plus c equals 0 format. So that will be something like 0x plus y minus k equals 0. And the point that we're getting the distance to is the center here. So I can mark that in the diagram. It's good to update your diagram with info. So then the formula, I'll write it in here so you understand what's to be done. For those that found this question confusing. by1 plus c over square root of a squared plus b squared. This here is x1, this is y1, because this formula gets the distance between a point and a line, and then the line we're getting it to is the orange line, and that has this equation here, where a will be 0, b will be 1, and c will be minus k. And the distance itself will be set equal to the radius, which is root 725 minus k. Right, let's sub all that in. So root 725 minus k equals the modulus of a times x1, but x1, a is 0, so I'll put it in though. 0 bracket minus 14 plus b which is 1, the coefficient 1, and then the y is 23. And then plus c is a minus k, divided by the square root of a squared, which is 0 squared, plus b squared, which is 1 squared. Yep, I subbed that in correctly. So what you want to do then is tidy that up. So root 725 minus k equals modulus of 23 minus k, and then there's just a 1 on the bottom. So what you got to do here then is square both sides, and you'll get a quadratic. So I'll just start that off. I'm not going to do it all. This is sort of easy from here. When you square the left, it gets rid of the square root. When you square the right, you get 223 to be squared. And then if you go through all of that, you'll get a quadratic k squared minus 45k minus 196 equals 0. And that has two solutions. So you'd be wasting time trying to factorize that. The numbers are fairly big. Just slap it into the minus b formula, and you get k to be 49 and k to be minus 4. So again, I'm pretty happy with those values. I kind of checked things in Desmos, so things are good. So we'll just go through an example of this. When k is minus 4, you put minus 4 in there. The radius works out as root 729. So that means the radius is 27. So the radius is 27 when k is minus 4. So think about it. If you have a radius of 27 and your y value was already 23, that means the line above is something like 50, or the line below is minus 4, if you think about it, because then you would go 27 away from your y coordinate. So that's what gives the minus 4. So that's the bottom tangent. And then if you put 49 in there, you'll get, like, I think a radius of 26. Yeah, and then the 26 adds to your 23 to get the 49. That's the top tangent. So the point is it works. Okay, cool. Good question. Good question. Right, this is a relatively easy question, but it's just there's a lot to do. That's just manual calculation. So like show this. So that's just a matter of going, and you'd want to show the workings for this. Don't pick up the calculator. You know, you're being silly if you pick up the calculator and type it in. You want to show what you're doing always. 6 plus 13, and then they're all over 240. So that should work out as a quarter, and it does. Yep. Okay, so then this down here, this was really bad, this one. Verify that this works. So look, A union C, I'm not going to do it, is I add up all of those numbers, right? And you'd have to show it, and then you divide all of them by 240, and then you show that's equal to a quarter for this, plus the probability of C, which you've got to then go and work out by hand, which is 13 plus 6 plus 16 plus 41 over 240, and then you got to take that away. From A intersect C, which is 19 over 240, and it just proves the formula. So there's no need to do that. That's junior cert stuff. There, don't know why they asked that. Anyways, this is a good question here. This is checking to see if students know that there's a formula for checking if two events are independent of one another. So we're checking if A and B are independent. So the formula that checks that is that if the intersection of the two things is equal to the two things multiplied together, that means that they're independent. Okay. So then we can see the intersection of A and B is these two things. So that there is 24 over 240, it's a tenth. And then probability A we already got as a quarter. And then we can work out the probability of B here by hand. It's adding up those 4 digits there. I'll write it in. 18, it's a terrible 8. 18 plus 6 plus 16 plus 56 over 240. And that left side works out as a tenth. So then you get a tenth equals a tenth. So yeah, and they are independent because that formula up there works. So yeah, that's grand. So then so there was the first few questions here are very similar. So in the sense that there's been some very straightforward, easy stuff to do, and then there's kind of a tough one at the end here. So what they're saying here is, so you can read this carefully. I'm going to go up above and show how to do it. I'll just need two probabilities from above, so I'll write them down. So if you go to all 3 countries, the chances of that are there's 6 people that done that. And then the people who didn't go to any of the countries, there's 67 of them. They didn't go to any. So what they asked down here is 2 people are picked at random. Find the probability that one of them went to all 3 countries and the other went to none of the countries. So you got to be careful here. There's an order thing that matters. So this can be done 2 ways. The first person you picked went to all the countries, so that's like a yes. And then the second person was the one who went to none of the countries. Or you could do it the other way. The first person was the person who went to none of the countries, and the second person was the one who went to them all, so that's a yes. So we worked that out by hand. If you went to all of the countries and you were the first person picked, that's 6 over 240. You went to none of them then, so that's 67 over 239. Okay. And then that's an or, so that's a plus. So if the none person was the first person picked, that's a 67 over 240 chance. And then the second person you picked, went to all the countries. That's a 6 over 239. So yeah, you got to watch out there with the order on that one. So that works out as 67 over 4780. Okay, grand. Moving along. So this sometimes these are very tough when they give a list of numbers here, but they made this one very tame. This is a very easy one. So there's when you want to work out the median, you use this formula. Q2 is known as the median, and you use a half n plus 1. Okay, n is the number of numbers. In this example here, there's 12 numbers. So Q2 is a half 13, 12 plus 1, and then that works out as 6.5. So that means take the 6th plus the 7th and divide by 2. The 6th number is x. The 7th number is 18. So then all you do here is you go x plus 18 over 2. That is the median, but you're told the median is 17.5. So that means x is 17. Okay, so yeah, that was pretty grand. And then once the interquartile range. So yeah, look, I like that question because sometimes people don't learn how to get the quartiles. So Q3 is 3/4 n plus 1. So then that's equal to 3/4 of 13. And that works out as 9.75. And what that means is to take the average of the 9th plus the 10th and divide by 2. I think the 9th and the 10th numbers here were 19 and 22. So the average of that is 20.5. And I checked that in a calculator as well. You can put all the numbers then, because you know that number 17 into a calculator, and it can tell you what Q3 is. And yeah, it works out as 20.5. So then the interquartile range, I call it IQR, is Q3 minus Q1. So then that's 20.5 take away 13. So that works out as 7.5. Cool. Cool. Right, this was very soft as well here. Just an understanding of who would not change here. So the median, if the number that changes is already the biggest number, it stays in its same position all the way out at the end. So the median would remain unchanged there, and the mean would be the one to change, because the mean would have to be recalculated with the sum of all the numbers divided by 10. So the mean will be the only one to change there, and the median won't change. Okay, yeah, after that, the biggest number is made even bigger. So grant the median's unperturbed by the outlier at the end. Okay. Yeah, this was a reasonable question too, because again, sometimes people, they just don't take the time to learn how to work out means from tables like this, grouped frequency tables. So what you do, you want to show all your workings. Yeah, use the work below to show your workings. So we know the mean, so we said 40.4 equal to 27 times 4. So you multiply them together, times 33, I believe it is. Yep, 33 times 5 plus 39 times 9 plus 45k plus 51.4 times 4, and then plus, you do have to show this, but it's sort of easy marks, and then you show yourself dividing all of that then by 4 plus 5, all the sum of the frequencies, plus 4 plus 2. Grand. So then you'll simplify that up and you'll get 40.4 equals the numbers on the top tidy up to be 942, and then you get a 45k, and then on the bottom you get a 24 plus k. And then you do a bit of algebra, you multiply across by the bottom, move everything around, and you'll get k on its own. K will work out as 6. And 6, does it have units? No, it's a number of people. So k isn't like in years, it's just a frequency. So doesn't have units, you don't have to worry about that. And I put all this into a calculator then afterwards with k in as 6, and yeah, the mean works out as 40.4. So k is 6. Okay, moving along. So 5 then, yeah, 5, some people don't like these. 5 was maybe a tough question. So you want to prove that these guys are congruent, so not to mix up congruent triangles with similar triangles. Congruent triangles are exactly the same. They're just spun around, whereas a similar triangle is the other triangle. Everyone has the same angles, but one is sort of scaled up. One is a bigger one. So these are identical. So the way I mark these is I mark the angles, I call them 1, 2, and 3. So I say angle 1 is equal to DCA, BCE, and the reason, the justification is they're opposite angles, okay? These, which I'm calling angle 2, and that's their names, you have to give their names as their alternate angles. Now, because two angles are the same in both triangles, the third has to be the same. That's one reasoning, but you could just say 3 is the same because, again, alternate angles. Now, I've proved they're similar, right? I've proved they're similar triangles, but I want to prove they're congruent. So if you read it up here, it tells us that C is the midpoint of AB. So I can put some dashes there to say that AC equals CB. Okay. So then I can use ASA, and ASA you have to use like an angle, side angle. The two angles have to wedge the side. So if I want to use this side, I have to talk about angle 3 and angle 1. I do that there. I say that the sides that are wedged between, the side wedged between angle 1 and 3 on both match ASA, so then they're congruent. So yeah, there's enough there to do the examiner. This was tough. This was a tough question. The scale factor part 1 wasn't that tough. So all you wanted to do here was show that x to q was 8, and then this extra bit was 4. So in total, that's 12. So then this k is just 12 over the smaller version, which is just out to q, which is 8. So k works out as 1.5. So I'm sure most people, even if they didn't know much, they would have had a fair, reasonable attempt at that one. Now, this is tough down here. So what you want to do, I'll try to build this up where I came from with this. So I marked in my 3 first of all. That was the very first thing I marked in. And then I still have my information from above that from x to q is 8. So then I can mark a 5 there, and then there's a 4 there. Okay, so the bottom 3 numbers make sense. So then I go and I use the fact that the area of PQ or S, that parallelogram, is 20. And then the formula for the area of a parallelogram is the base times the perpendicular height. So if the bottom was 5, then the height there had to be 4. So that's where the orange 4 comes from. Now, because of the scale factor k, this height is 6. Because the height of the parallelogram gets scaled up to make the bigger parallelogram. So that's where the 6 comes from. And then because that's 4, then I can mark a 2 in there. So you see I'm just kind of building up my diagram as such. Okay, so then the big thing then is where does the 3.5 come from? So yeah, I want to get the base length of this guy here. So there's a trick here. One trick can solve this pretty well. In 1 dimensions, if your scale factor is k, in 2 dimensions, in terms of area, the area scale factor, say area 2, would be equal to the first area multiplied by k squared. So you had to know that 2D scale factors are k squared. So if the area of the small parallelogram was 20, well then the big area for the big parallelogram is equal to 1.5 squared times the small parallelogram. And then that works out as, I think, 45. But because we know the height here is 6, well then we can work out the base. Because 45 then will be equal to 6 multiplied by the big parallelogram's base, I'll call it A. And then 45 divided by 6 gives 7.5. So A is 7.5. And so that's where the 3.5 comes from, because you take the 4 from the 7.5 to get the 3.5. And sure, then once you have 3.5 there, you just get the area of the shaded parallelogram, which is 3.5 times 4. And then that works out as probably 14. It does. So yeah, I'd say the big thing there for people was if they knew or not that the 2D scale factor when you're in 2 dimensions is k squared. Okay, that was a good question. That's there needs to be more of that kind of stuff because it's, you can still kind of fill in things in the diagram, pick up marks. So it's, it's a tough question, but people can still attempt it. Okay, this was a good flavor of a difference. So these are a common question that come up like every second year, but this was they added a little difference to it here. So between 0 and 360 degrees, this thing has just 2 solutions, right? So then we got to find 2 more solutions from 360 to 720, and then 2 solutions before from minus 360 to 0. So let's just find the first 2 solutions in the first quadrant, in the first spin, first rotation. So what we do is we take sine inverse of a half to get the first quadrant angle, and that works out as 30 degrees. Okay, now where is sine positive from your cast diagram? Sine is positive in the first and the second quadrant. To move an angle into the second quadrant, we go 180 minus theta. So then the other solution is 150 degrees. Okay, so what we do then is we split the page down the middle for these types of questions, and we set that the angle, which is A, we say it's equal to 30, and we also say it's equal to 150. But then we add on 360n to deal with the rotations. So that's the general solution. That generates all possible angles, right? For every range of angle. Now, we're interested in going between here and here. So what we'll do is we'll set n equal to 0 first, and then we'll get the 30 degree answer. And we'll get the 150 degree answer. We'll set n to be 1, and we'll get the 390 answer. And probably 510 over here. Now, if I go n equals 2, I'll do it anyways. So you see this will go over 720. So this is like 750. And then you just put a line through that because that's gone too big. Now I want to go the other way. How do I get the other one? So this was a smart thing here. So like, to be honest, most people could have gotten this far. So this was a good, fair question. So n equals minus 1 was the trick. And then that gives you a to be minus 330 degrees. And then a here works out as, was it minus 210? Minus 210, yeah. Now, the good thing about this is you can move on from this happy when you've done this correct, because you can put all 6 of your answers back in here using your calculator, and all 6 will work out as a half. So it's like, you find the roots of a quadratic equation, you can sub them back in to verify they're correct. And so that's the same here. You can check all 6 of them values and be sure they're right by, and know you've got the marks for it in the exam. Okay. Right, this down here then, this was good. I like this. This got people thinking to see if they understand what modulus does. So when you're dealing with straight lines, say there was just a linear straight line like this, that's where we see it most of the time. Say his equation was like x minus 3, not far off what it probably is there from that diagram. So then the modulus of x minus 3 is a V diagram because it's not allowed to have this part. It can't go below, it can't have negative values. So it looks like a V, right? So when we look at the original graph of sine then, sine wants to start here and it wants to go down. But this down part is not going to be allowed. It's going to be flipped back up and you're going to get something like that. So the diagram, so if that original diagram there is y equals sine x, okay, well then the modulus of sine x will look like this. And then it's not allowed to go down, so it has to come back up like this. So that's the graph of y equals modulus sine x. Now, when is it doing this? It wants to drop down there at pi. We're in radians in this question. So that's actually a full cycle when you look at the shape here. It goes down, comes up, and then it goes down and up again. So, and up. So then the period here is actually pi. because of the graph. Now, in terms of the range, if you put a 4 here, that just brings everything up to between 0 and 4. Okay, and then if you put a -1, you take 1 away from your y, it drops every value down. So it's like grabbing this graph here and just moving everyone down by 1. It's done very roughly there. So now you go between 3 and you go between -1. So it's -1 to 3. Yeah, and you can just type that into Desmos there and you'll see that it does this behavior. So yeah, that was a good question. Nothing wrong with that. Okay. Yeah, happy with that. Yep. This here, this was okay. Nothing wrong with this question. Most people will be able to use the sine rule, and then or the cosine rule, and then you have this instruction here not to use the calculator. So let's see how it goes down. So you want to apply the cosine rule. So a bit like 2 squared equals 3 squared plus 4 squared minus 2bc cos, and we'll call this theta, cos theta. And then you move this around so to get the cos theta on its own. So this is where I actually began the question from. So it's 2 squared minus 3 squared minus 4 squared over, I forgot a 2 here, minus 2 times 3 times 4. Okay. Yep. So then you tidy that up and you'll get that cos theta is equal to minus 21. Yeah, minus 21 over minus 24 on the bottom. So then that works out as 7 over 8. Now, how do you get tan theta from that? So what you got to do here is you got to draw a triangle. That's the tricky bit. A lot of people might have gotten that, and that would have been worth a good few of the marks. But you got to know to draw a triangle after this. So if you know cos theta, you can work out sine theta and tan theta from a triangle. So then this side here would be known as 7, and that's 8, because that's the adjacent and the hypotenuse. Then you can use Pythagoras to get this side, which will work out something like that. Okay. So then you can just write tan theta, and tan theta is opposite over adjacent. So then that works out as root 8 squared minus 7 squared over 7. And 64 minus 49 is 15. So then this works out as root 15 over 7. And that's in the format they want. So that was a good question because kind of covered the triangle thing, and then it gave people an opportunity to pick up some marks using the cosine rule. So that was a fine question. Right, yeah, this here. So someone at the Department of Education can use SolidWorks, because that's where this came from. You can tell by the shading. You know, I think it's a bit silly making people measure something like this in centimeters, but yeah, get people a bit comfortable, I suppose, going into section B. So maybe not the worst thing in the world. I measured them as best I can on a PDF, and I got 1, 10, and 3. And then that's just using a ruler. So then I was told this is 90 meters in total. So what I done there was work out a scale factor. So I said K, the total here was 14 centimeters. So then I put 90 meters over 0.14, because 14 centimeters is 0.14 meters, and I got a K to work out as 4500 over 7. So then I just scale all of these up. So this one here, the 1, I'll do maybe the 3 at the end so you can see. So to get what the 3 works out as, I change it into meters, so it's 0.03, and then I multiply it by the scale to get into the big meters, and then that works out then as 19.3 meters. Just double check that, and you can see all those numbers there add up to 90. 0.03 multiplied by 400. Yeah, 19.3. Okay, happy with that. So yeah, fair enough. This was good. So then they put in bold here, once you get X, not to stop, but to actually give them the total length. So this isn't too bad. I'm sure most people would have been able to go with it. So the volume of that thing is a hemisphere, and the volume of a hemisphere is 2 over 3 pi r cubed, or is this, plus volume of a cylinder, which is pi r squared, x is the radius, times the height of the cylinder, 7x, plus volume of a cone, which is pi over 3 r squared, which is x squared, multiplied by the height, which was 4x. So let me confirm that's correct, what I've written there. Yep, that looks fine. 7x cubed, and that works out as 4 pi, yeah. So when you tidy all that up, you can do factor out your x cubed, because it'll be an x cubed in every one. And then sub in 6738 for v, you'll get that x cubed. And this is what you'd want for the examiner now. You wouldn't want to be subbing this stuff in for a calculator. You want to be able to do your algebra to move things around. This works out as 2 pi over 3 on the bottom, plus 7 pi, plus a 4 pi over 3. You can see where I got them from. And then you can don't even need to put that into calculator, you can put just power a third. So that literally I only pick up the calculator at the very end, and I get 6.2 meters for x. And I confirm that with a calculator, so it is 6.2. Okay, and then you don't stop there. You got to remember you want the total length. So the total length is 12x. So then you want to multiply that by 12 to get the total length. So 12x then is 74.4 meters, like such. Okay, cool. Fair question. This wasn't bad either. This was okay. This was okay. Write down the equation of S. S is the circle on the right, so that's x minus 20 squared, y minus 0 squared, and then r squared equals r squared, so that just works out as 178. Happy days. Now, these 2 points are vertical because we can see that they have the same x value. So we know that CD is a vertical line. And then we're asked to show that this lies on S, so that's pretty soft. There, all you do is you put the point into the circle to see if it works. So we're putting 7, 3 in here. So that will work out as minus 13 squared plus 3 squared equals 178. So then that's 169 plus 9, and then that's 178. So 178 equals 178, hence that point is on the circle. Okay, soft marks. By using the fact that these 2 points are vertical is what they're kind of saying here, find the area DBC. So let's mark that in here. Right, so that's vertical. So what you can do here is, you know that this goes 3 above and 3 below, so then this has a base of 6, and because this is located at 7 and this is located at 20, the height here is 13. So then you can just go, the area of that is a half the base, which is 6, multiplied by the perpendicular height, which is 13. And that works out as 39 meters squared, unless things are in kilometers. They are, so that will be kilometers squared. Yeah, 39 kilometers squared. Now find the angle in this triangle. So let's do that. So CBD, yeah. So CBD is this angle in here. So to get that angle, let me clear that away. It's maybe a good idea to split this big red triangle up into a smaller triangle here, like this. And then to call the angle, not theta, because we're looking for theta, call it theta over 2. Okay, so I'll draw that bigger so you can see it. So we're calling this theta over 2. We know because this was a total of 6, this is 3, and then this is still 13 down here. So then we can write tan, opposite and adjacent, tan theta over 2 equals 3 over 13. So then we do tan inverse, and then we can, yeah, I'll show the steps. Theta over 2 equals tan inverse 3 over 13. So then theta is double that. What did I get that to be? think 26 degrees, yeah. 26 degrees. Yeah, that's a very reasonable, fair question. Nothing wrong with that. It's a good balance of stuff, you know. It's nice to see stuff like that in the Leaving Cert. This was good as well too. So they wanted you to get this shaded area, but they kind of lightened the workload on you by giving you some values here, you know. So the way we do this here to get that shaded area is we get the area of all this sector here, and we get the area of all that sector there, and we get the area of this triangle here. And then we take them away, and then we get this shaded area here, just this little shaded bit at the end. And we do the reverse of that over here with this sector and this triangle to get this other shaded bit here on the left. And then that gives us the total shaded region. So what I'm doing is I'm taking a sector on the left away from a triangle on the left, adding it then to a sector, take away a triangle on the right to get the area shaded. So I'll just write the solution here. I don't think this is too hard. So they gave us the first sector, 23 to this many significant figures. So we'll try and keep that many significant figures. Take away 21. Yeah, take away 21. So that's the sector minus the triangle, plus us take away our sector and triangle. So our sector is, if you look at the formula for a sector, it's pi r squared theta over 360 when we're in degrees. So then I go r squared, the radius of that right circle was, remember, root 178, so I write 178 here. The angle we worked out to be 26. So that's the area of the sector. Then we take it away from the area of the triangle, which we got previously to be 39. And then, yeah, so you could type all that into calculator, but in this scenario, it's actually not a bad idea to work everyone out individually. So you can see that the shaded region, remember when we split this in two, the shaded region on the right is bigger than the one on the left. But again, you could fire the whole thing into a calculator, but it wasn't bad to show this. 28370, keeping 6 significant figures, and then this was 138. So I don't usually do this at all, I would just say throw it into the calculator, but I thought it was a nice thing to just see both those areas there to see how they add up. So then in total it becomes to 2 decimal places that kilometer squared. Okay, cool. That was a nice question. Nothing wrong with that question. Okay, so what do we got here? So this is a 3D problem, and 3D problems are solved by drawing 2D sketches. So you got to draw a 2D sketch here of, say, this triangle. And you want to draw a 2D sketch of this triangle. So you mark the 3D diagrams in first of all, and then you bring them onto a page here. So this is me drawing the red thing. This would be your workings as well. This here, because it's square base, this one will have 6 and 6. From Pythagoras, this works out as 6 root 2. The bottom of this guy is half this guy's diagonal, so then this is 3 root 2. So that's half of that, so it's 6 root 2. You want to show the workings over 2. Because that's dB there, and you can mark it in, that's dB. You can mark the O there if you want. Yeah, that was fairly easy. That's not hard. This is 3 root 2 then. This is 11 from your diagram. So then this is x. So then x equals the square root, the hypotenuse squared, minus 3 root 2 all to be squared. And I got that to be root 103. And it said leave your answer as a third. Ooh, there's probably a bit of units here. You want to slap a meters on that. Could get penalized a mark if you didn't put the meter in there. Yeah. Tricky to remember to put the units in when the answer is a third. Okay, right. Next thing, I think we're getting an area of a triangle. We are. So we're getting the area of this guy here. So then again, we want to draw 2D diagram of that thing. This here is 11, this here is 11, this here is 6, and this is the angle they're on about PAB. This here is 74.2. To get the area of that, you use a half AB sine C. As a rule, A and B have to wedge the angle C. So this would have to be your A and B, 11 and 6, if that's going to be your C. And then because there's 4 of them faces, of the 4 triangular faces, we'll multiply the answer by 4. So this will be 4 big A total on the left. You want to always have things equal to stuff, so don't be just writing stuff without it being equal to something. 4 bracket a half times 6 times 11 sine 74.2. And that should work out A total. I've got 127 meters squared. Okay. Yeah, this here, it seems easy, but you know, you could take away marks from people if they're not doing it properly. Okay, so you want to be you want to have a proper compass, not those stupid compasses that come with the sets that you put a pencil in yourself and then you tighten the thing and then the thing's coming loose and whatnot. There's proper compasses that they use in TechGraph, and important to have them when you're doing your maths. So what you wanted to do here was you wanted to find the center of the, well, there's loads of ways to do this. Okay, this is just one way. You join those two diagonals together, and then you'll get the center of this. Okay, so you have the center now of the square. So then you get your compass and you dash this line out here, so that you then spin around part of the circle to get this dash out here, right? So then all you got to do is join. You want to find maybe the center here, but what you could do is, look, you could just get your ruler and connect your ruler down through here as a dash to get the center of that there, and then you just connect these two lines. So yeah, you need to dash this, and then you need to also find the center of this dash by dropping a sort of perpendicular thing down there. And then that gets this point here, and you connect this point here to these two vertices. And so you have this guy here, this triangular face. So then you want to get another triangular face. And one easy way to do that is to put the compass here, dash out here, and then swing the dash over here. And then like what we done there before, we put the ruler lined up here, and then you drive a line all the way back here, and where that line hits the dash, that's this point here. So then you just connect that point to this point here, connect to this point here, and then that's them two guys mirrored through this point of symmetry here. It's one way to do it. So yeah, and you probably did want to show a few construction lines there. So look, there's probably only going to be 5 marks for that, maybe 5-10 marks, depends. It's not going to be a big, easy enough pick up marks there. Yeah, this is a good one here because people are supposed to know the percentage error formula. So I'll write it up here for everyone. Percentage error equals the value you measure. So let's say that, let's get a good name for this. What you measure minus the true value divided by the true value multiplied by 100. So when you use your tan here, tan theta equals 17.5 over 15, and you do tan inverse, I think to 1 decimal place, that thing works out as 49.4 degrees, and she measured 52. So then the percentage error is 52 minus 49.4 over 49.4 multiplied by 100. And then that gives a percentage error of plus. No need to put the plus in, but it's a good habit because sometimes percentage errors work out as negative. So there's an error of plus 5.3%. I think I got 5.26, and then we were told to round it to 1 decimal place. Okay. This down here, I like this question. This, you know, if you put the time in and you've practiced in the book, you would have solved a few of these. Like literally from the textbook, there's questions identical to this. So for those who done them using the sine rule, they'd be grand. But they were very nice here. They told people to use the sine rule. So again, you know, they're holding your hand here, guiding you through things. So use the sine rule to find x. So let's go through how we do that. So you can populate your diagram with so much stuff. Like, that's 90 there. This is 145 here. All these three angles add up to 180. So then that puts a 13 up here. And then because there's a 13 there, you know what's here as well, because that's 35. Now we don't use this angle, but it's just making the point that you have the full diagram, So to fill that in. Anyways, we can use the sine rule here. So we can say that this side here, the 10, is opposite the angle 13, and the x is opposite the 145. So we can say x over sine 145 is equal to 10 over sine 13. And again, you don't want to be typing that into your calculator. You want to move it around like it is, and then call it 10 sine 145 over sine 13. And you want to fire all that into your calculator. And you'll get it to be 25.5. Yeah, okay. That's all right. So that was a relatively soft question. I think this is the end. So there's been relatively those first two questions have been reasonable enough, and I think the last question in this paper as well, the stats one, is reasonable enough. So there were three easy enough questions you could do. Anyways, where are we here? So we've got the x to be 25.5. Right, so then you want to find h. So I'll draw this big triangle here that includes h. So then I've drawn it on my main diagram, but then I'll do a sketch of the triangle over here. Good habit. This here is 22. This here, now what's this distance here? This distance here is h minus 1.25. That's the way to go. That's what to call it. And then this is 25.5. We have the opposite and the hypotenuse here, so we can write sine 22 equals the opposite over the hypotenuse. And then we can multiply across, so 25.5. Ooh, 5s are starting to look like s's now. Not good. 22 equals h minus 1.25. And so h then, see, I'm not using a calculator, I'm able to move it all around. 25.5 sine 22 plus 1.25 is h, and then your answer would want to be in meters. And I got that to be 10.8 meters. That's the height of the tower from the ground. Okay, let's clear that away. And then that's the height of the tower. Cool. Yeah, this question here, these, if you've done enough past papers, this is kind of question has come up maybe 2 or 3 times, so it's reasonable enough. Like when you're given a probability here, 1 minus it goes down here. They tell you this in the question is 99%, and then that puts a 1% there. This was given in the diagram, so then you can take that away from 1, get there. To get these numbers at the end, you just multiply your way along. So to get this number, you go this multiplied by your pathway here, and you get this. And then you can double check that they all add to 1 at the end, and they do, and I checked that. So that's that there. They're easy enough to fill out. Find the probability that a person picked at random tests positive for diabetes. So that's these people, and then that's these people added together. So if you add those two things I've put in red together, you'll get 0.1391. And then there's a really good question here. So let's study this. The person picked at random tested positive. Find the probability they actually have diabetes. So what this is saying is we're looking for the probability that the person has diabetes given they've tested positive. It's given probability, this. And the formula for given probability says that on top you're meant to have the intersection of those two things divided by the last thing mentioned, which is the probability of testing positive. So then that's our formula. We come up here. The intersection, what does that mean? That's the probability of having diabetes and testing positive. That's this one. 663. And then this is the probability of testing positive, but that's what we just worked out in the last question. That's these two things added together. 0.728. And when you put that into a calculator, that works out as 0.4766. So yeah, you can, look, some people as well would have just been able to think about that for a second and realize what I'm supposed to do here is take this and divide this by the two things added up, and you'll still get your full marks. But it's nice to understand why that is what you do. Right, let's move along. Yes, okay. So this question 9 was a bit tough, you know, it was a bit tough overall. This here is a Bernoulli trial. This is a bit tricky. The 2 or more. So the way to do 2 or more, probability of 2 or more is equal to the probability of exactly 2 successes plus exactly 3 plus exactly 4 and then plus exactly 5. Now that takes a load of time to write all that out, but there's a quick way to do this. This is also equal to the probability 1 minus the probability of exactly 0, 1 minus the probability of exactly 0 plus the probability of exactly 1. So you can get all those scenarios there by taking one away from the 2 scenarios that's not included. So that's the quicker way to do this. So we go 1 minus 0 successes here. So that will be like 5 choose 0. And the successes you could say is picking someone who has the diabetes. So that's 0.067 to the power of 0. Take that number away. We had that before in our tree diagram. That's the power of 5. Again, I want to have my square bracket here. Plus 5 choose 1 times, and this will be the workings that you'd have to show for this. Not just chucking the whole thing into a calculator. And that's the probability of exactly 1 person. Okay, and then I typed all that in and I got 0.0392. Right, that was that. And then there's this miserable section here now. It's hard to put this into words. So we'll get the first thing out of the way here. This isn't bad, you know, there's 20 people. How many different ways can you pick 10 people? You know, that's all this is. This here is just 20 choose 10, you know. How many people, wait, can you pick the 10 people for group A? And 20 choose 10 is 184756. So that's just a combination, you know, choosing 10 people from 20. Now, so we'll have just to talk about these two questions here. So these two questions appear at the end of question 9, okay? They're extremely badly worded, and the person who wrote them didn't make very clear what a set is, okay? So you could easily mix up what finding a unique pair is with actually then the pairs have to be put into a set. So it's definitely not explained very well. So hopefully the marking scheme gives both of these 5 marks each, and then students can get anywhere between 2 to 3 marks for attempting anything. And hopefully whoever wrote this question loses their privileges to write similar questions like this for the Leaving Cert, because this is, you know, this isn't a good question in any way. You know, you can't really study too well for this. You know, this isn't the type of questions that are covered a lot in textbooks. There's loads of interesting combination questions you could have came up with that would have tested people, but these were just stupid. Okay, so a common trap here would have been to think that, okay, we're just kind of looking for the number of unique pairs here. So 10 people are picked and put into group A, 10 people are put into group B. And these make 10 pairs, as you'd imagine, when you pair everyone up. How many different sets? This word here should have been in bold, and it should have explained to you what a set is, maybe with a smaller example. So the trap here is to think, okay, we're just making pairs here. So, maybe this is just 10 by 10. You know, we take, this is the number of unique pairs, right? Where we took 10 from the first group and paired them with 10 in the other. So there's 100 unique pairs. but we're not looking for pairs. We're looking for the pairs then have to get put into a set, and we're asked how many different sets there are. So it's not, and you can't just go like, oh, well, we know there's 100 unique pairs. Okay, then let's just take 10 of those pairs. Okay, so then 100 choose 10. But you can't do that because some of the pairs that you're going to pick here will already have a person in it. So it doesn't work like that. So the best way I can explain how this works is, let's imagine the people in group A all lined up to pick a partner in group B. The first person walks up and they're to choose someone from group B. So that's a bit like 10 choose 1. Right, that person is picked up. The next person in line A approaches and they pick someone from B. There's only 9 people left. So it's 9 choose 1. And that goes all the way down like that to 1 choose 1. The last person lined up in A picks the last person left in B. And they've made pairs. They've made their pairs there. And that's what the answer is. So that actually surprisingly works out as 10 factorial. Okay, and 10 factorial is it's a big number. I don't have the number there, but you know, I'll work it out here. It's 3628800. Now, one question you might have here is, okay, you're saying people in group A are lining up, but doesn't it matter which order that the people in group A are lining up to be paired with that person in group B? Now, fair enough, when we do like a combination like this, we're saying that, okay, we're not really picking an order here for the group B people. But for the group A, it's like you're saying just a random person in group A is at the top of that queue to pick someone from B. Does the order in which they're in that queue not matter? And the answer is no, because the order in which the pairs are made and placed into the set doesn't matter. So it doesn't matter what order the people who came in from group A were in. So hopefully that makes sense. One way to think about this, as we said here, I'll show you another way to think about it, is let's say the order does matter of the way people are grouped in A. So we said it's 10 factorial to pick the people from B. So then if we look at the specific ways that the people can line up in A, that's like another 10 factorial. But as I said, they're making pairs now. That's the number of pairs with an order. But then you have to place these into the set. And the order in which they're placed into the set, we don't want it to have a specific order. So we got to delete that order out because there's 10 locations within the set. So you delete that out and you get back to the same thing. Look, it's a very difficult thing to make sense of because we're talking about sets here and not just pairs. So it's something to sit down and think about and maybe have a chat with something like ChatGPT or something. Have a long discussion about this question and why the answer is just 10 factorial. Because it's a difficult thing to go over and explain it several times in several different angles until people can pick up on what's going on there. As I said, it's a tough, rotten question. This one here, this is even worse. So what's going on here is we're doing it again. So again, they decided let's do this rubbish of sets. So again, too, you might say, okay, what's the specific pairs here? It'd be something like, you know, oh, there's 8 people in the first group that we could pick that then get matched with 16 and then maybe 5 here, you know, or 15, something like that. So that would be the number of unique pairs. But again, we're not looking for pairs. We're looking that the pairs then have to go and get put into a set. And there's going to be 8. There's going to be 8 sets because a set is made up of 1 person from group X and 2 people from group Y. So it's a bit of a sickener. So one way to think about this is, again, let's line up all the people in group X. Let's have them all line up. And then they have to go and pick 2 people from group Y. And we don't want there to be an order here. We don't want to pick, say, Jack and Diane from Y, and then to have that as another pairing if we pick Diane and Jack. Okay? We don't want that. So the way we delete out the order here is by saying first person from group X approaches, picks 2 out of Y. That's like 16 choose 2. Okay? First person from group X came up and picked someone from group Y. Picked 2 people from group Y. They had 16 to choose from, they picked 2. Great. The next person then approaches from group X. They have just 14 people to pick from and they have to pick 2 of them. So that had to happen and this had to happen. And so the next person from group X approaches and does this, and the thing keeps going all the way down. Now you could type that into, there's not that many of these. And that is the answer here to this question. What that works out as, now that has there's a simple way of working that out. If you remember how to do these by hand, this is 16 times 15 over 2 by 1. This is 14 times 13 by 2 by 1. So what this actually simplifies to, without having to type the whole thing into calculator, it's that. It's 2 by 1. You could say 2 factorial on the bottom, but 2 to the 8. Yeah, it's a tricky example. So what I'll highlight then again here is the thing I mentioned before, is like, oh, I said that they lined up in a specific way in group X to pick their two partners from Y. Does the order in which they lined up in X matter? Again, it doesn't matter, because the order in which they get placed into the set which is made of 8 pairs, doesn't matter. So we don't want to go working in an order here for the people in X. Now you could do that, and their order would be 8 factorial, but then you'd have to delete out the 8 factorial down here, because we don't want to be putting the pairs in a specific way into the set. Okay. So again, too, it's a tough question. Sit down with maybe ChatGPT, have a long discussion about it. Yeah, that's the cleanest way I can think of explaining this shitty enough question. That works out as, what's the number for that? I think if you type that into calculator, I think you get like 173 by 10 to the 10 or something, as far as I remember. I'll do it here again, just check. 16 factorial over 2 to the power of 8. Yeah, that number. So I'll do it again. Stupid question. So here we go. This was nice. This is people who studied and they learned what the empirical rule is. 68% is between x bar, or mu, plus or minus a sigma. So x bar, I'll call it mu, its proper name is mu, is 400 plus 60 and minus 60. I'm sure most people got that. Then you add, this is the 2 sigma, then this is the minus 2 sigma down here, the 280. So that's all fair enough there. And then use your normal distribution tables to get this. So the workings for this is you'd write, first of all, you're interested in x greater than or equal to 420, right? And x, what am I saying? Oh yeah, x for sure. We're in x's here in this question. Grant, and I don't like to put the equal sign in there, so let's keep it consistent. So z equals x minus mu over sigma. Z equals 420 minus 400 over 60. You'll get a Z score there of, was it 20 over 60? I think I got 0.33. You rewrite this statement now as the probability that not X, but Z is greater than 0.33. Okay. To get the area above this Z score, you go 1 minus what's below it. That value then comes from the tables book. So that's 1 minus that value from the tables book is, I think, 0.6293. So then the answer to this question is 0.3707. And then it just wanted the answer to 2 decimal places. So you could probably write that as 0.37. Yeah. That's I think that's fine. So that's the people who scored above 420 in the test. It's only 37% of people. Okay. X's into Z's. What's above is 1 minus below. So I think that's all handy enough. People would have done that if they revised for that stuff. This here was also okay. This was fine, I think. A 95% confidence interval. So you just need to know your formula. Sigma over root n. We're to do this for country X, so we go 387 plus minus 1.96 multiplied by 66.2 over root 2161. And then that gives a mu in the middle, and then the lower limit I got to be 384.2, and then see, it's a very tight interval, 389. See that? See how tight it is? And the reason it's so tight is because the sample size is so big. It makes the confidence interval very tight. Okay, I think I've written that, and the units there are just marks. I think it didn't tell us what the thing is, so I think it's marks, the units. Okay, yeah, I'm happy I've written that. And the next thing is a hypothesis test, and you know this is very nice here. I don't think this is too much holding the hand. I think people have a hard time deciding the hardest part of hypothesis tests, and people really struggle with who is H0 and who is H1. So I don't mind them doing this, just telling the students H0 is when mu is equal to 400, and then H1 is when mu does not equal 400. Nothing wrong with that. So here it wants you to just get a test statistic for this. So we scroll up. We're dealing with country Y here, aren't we? We are, yeah. So we get a z-score for that test statistic. So we use the formula x bar minus mu over sigma over root n. And you'd be like, oh, here, sure, the mean is 400 and this is 403. Their mean score surely is 400, but this is a huge sample size, and as you're going to see here, we actually have to reject this, so we say that the mean is not 400. So the fact that that's so close to 400 can be deceptive if you don't take into account what the sample size was. Minus mu over sigma, which was 70.6 over root 2724. Yep. So we get a z-score there of 2.22, and that means we reject H0, but I think we keep that conclusion until down here. It doesn't want us to finish it, so it tells us to do this here. So we got a z-score there of 2.22. We're asked to work out a p-value for that. So there's the p-value formula. P-value is an area, and it's the area outside our z-score. So I'll do this because people, a lot of people don't know what a p-value is. So there's 0 in the middle, and then we've got our z-score here. I'll mark it in of 2.2 minus 2.2, and then a plus 2.2. And the p-value is just the size of this red area plus the size of this red area. So that's what a p-value is. It's two areas added up either side. So the formula for the p-value is just an area formula. So you go 2 times, because there's 2 tails. The way to get what's above 2.2 is to go 1 minus what's below 2.22. So we go 1 minus the probability that z is less than 2.22. Now my z's are looking like 2's. But that's z less than 2.22. Go to your tables then, showing your workings, because you want to show yourself getting this value, I got 0.9868. Yep, and so the p-value works out as 0.0264, and that's a small p-value. That's a p-value less than 0.05. So that's still, that is reject H0. So this is your conclusion now. You reject H0 at the 5% level of significance. This is important, okay? Because if you were doing this test at the 1% level of significance, you would not be rejecting this because 0.02 is above 0.01. So that's why you have to state the level of significance that you're rejecting H0 at. And so we make our conclusion then, referencing the mean score. What this means, because we're rejecting H0, the mean test score for country Y is not 400. So that's it. And you can say it again at the 5% level of significance. As I said, if we were doing a 1% level of significance test here, we would not be rejecting H0. So just so people might be watching this later on, a p-value is the lowest level of significance at which you can begin to reject your H0. Okay? If we were doing a test at this level of significance, we would begin then to reject H0. Okay, but because we were at 5%, we're not rejecting H0. If we were at 1%, then we would have gone below the value. So hopefully that makes sense. A p-value is an area, and then it's the lowest level of significance at which you begin to reject H0. And here we rejected H0 because our p-value was below our level of significance. Grant. So that was it's been a nice question so far. I think this is a bit stupid. This is a great question down here, but this is a bit stupid. For one thing, the principle of what they're asking here would have been fine. I don't think they should have picked 50% and 50%. Maybe they should have said something like 30% have a pet and 70% doesn't. It would make the explanation a bit easier. So what stratified sampling is, it's where, say, you have 1,000 students in your school and you're interested in surveying them, right? You want to take, you don't just pick, you're sampling 100 people. You don't just pick 100 random people out of your 1,000 school. You want to pick a number of people from each year proportional to the number of people in that year. So for some reason, if the school has like 500 of the students in sixth year, you want to make sure that you ask way more people in sixth year from the 100 people you're picking at random. So if 500 are in sixth year, you would want to get 50 people randomly picked from your sixth year for your 100 sample. So hopefully that makes sense. Stratified random sampling is where you don't just pick everyone randomly. You pick a certain number of people based on how big the group they are that comes from. So you can have a look at what it means in the textbook, if that doesn't make sense. So what they're saying is here, we're supposed to pick these 2,500 students from these two groups, and this is why it's annoying. Both of them are 50%. So that means 50% of these students, 1260, would have to have pets, and 1260 would have to not have pets, right? It would have been nicer if they had a different percentage here. So those random people picked from that country, you have to be asking them, do you have a pet or not, to include them in this subset here for your sample. So that's how it would be performed. You would pick this number from people with pets and this number of people with not pets. Why wouldn't this be useful? Well, because why would having a pet affect your mean math score? So this isn't necessarily a good thing. It's not. There was no reason to break things up into their groups. And a better question would be the percentage of people that are on social media or something like that. So like 90% would be on social media, 10% are not. So that's maybe something that might affect someone's math scores. They're not spending as much time studying. So then 90% of these would have to come from people who use social media, and 10% who don't. And that would be an interesting way to use stratified sampling. Hope that makes sense. So yeah, it could have been a bit better, this question. This is very good. I like this. I like these questions. And this is the end of the paper. So we have to form a bit of a simultaneous equation here. The proportions should add up to 1. So we go 0.19 plus p plus 2r plus r. So that's 3r equals 1. Because the proportion should add up to 1. So we get p plus 3r equals 0.81. Right? We then can write the expected value, another equation, e of x. And that comes from multiplying the things together. So you'll want to show your workings for that. 0.19 plus 1 times p plus 2 times 2r plus 3 times r. So e of x equals, that goes to 0. It equals p plus 7r. P plus 7r is the expected value. Now, we are asked to maximize the expected value. The expected value depends on two variables here. So you're like, how do we can't take a derivative here because it depends on two variables. But there's a way they want you to think about this logically. E of x gets really big if r has the bigger value than p, because e of x is got from multiplying these two things together. Now, p is only ever going to be multiplied by a 1, whereas r is going to be multiplied by like 3, and 2r is going to be multiplied by 2. So if you want to make e of x big, you want r to be as big as possible, and then p to be small. Because p and r, r can't be big without making p small, because they all have to add to 1. So this was a constraint you had to realize, that to get the biggest value for e of x, you want to make this guy small, and then give all the value as much as possible to r. So here, which is the restricting statement, for how P and R relate, you want to set P to be equal to 0 here to give R as much value as possible. So then you get 3R equal to 0.81, and then R works out as 0.27, I believe. Yeah. And then you sub that in here for your E of X. P works out as 0 because we set it to 0, and we go 7 times 0.27. And then I'll just double check that value. It should be a little less than 2. Yeah, E of X here works out as 1.89 marks. Marks as well, you want to put the units in there. Okay, and then yeah, if you wanted to minimize E of X, you can redo this question where you set R to be 0 and then you give P all the value. And you'll notice you'll get a different, I can do that now. Because if we set R to be 0, then P would take all the value. So P would be 0.81 because R is set to 0. And so your expected value then would only work out as 0.81 times 1. So that's the minimum expected value. And the maximum was 1.89 when you give R all the value. Grand. Okay, yeah, so a reasonable exam. Look, it was probably a good paper too. There were some stupid questions. We said that already. But there was a good variation, particularly the fact that you have a bit of choice in this exam. So I think it was a good paper too overall. Okay. Thanks for watching, and best of luck in the rest of your Leaving Cert. Bye.